Hi, Algebra 1 students. This is Miss Graham here, and today we are going to be looking at lesson 24-1, polynomial terminology. So you're probably seeing this word polynomial, and you have no idea what it means, but don't worry, we're going to discover what that is today. So go ahead and pull up pages 355 through 358. Looking at our learning targets for starters, we're going to identify different parts of a polynomial, and we're going to identify a degree, or what the degree is of a polynomial. So let's go ahead and look below at this story problem that relates to real life. So a solar panel is a device that collects and converts solar energy into electricity or heat. The solar panel consists of interconnected solar cells, just like the ones that we see below here in the picture. The panels can have different numbers of solar cells and can come in square or rectangular shapes. So we know that this is the whole solar panel, and we know that each of these is a solar cell. So question number 1 says, how many solar cells are in the panel below? So after we count it up, we can see that there are 16 different solar cells. Now, if we continue down below, we can see that if a solar panel has 4 rows, as the picture does, right? We have 1, 2, 3, 4 rows, but it can be extended to have an unknown number of columns. So let's say it keeps going with the number of columns, right? We're going to use the number of columns as x. That's something that we don't know. So we want to write an expression that gives the number of solar cells that could be in this panel. So something that we want to think about is maybe how did we figure out how many solar cells there were here? Some of you might have counted it individually, but some of you might have said, hey, I have 4 rows, I have 4 columns, so I did 4 times 4 to get my 16. Well, now we don't know the number of columns. It's x. That's what we're using, the unknown number of columns. So that way the number of columns just keeps going on and on. So how could we write an expression that represents this? So we would use the same idea before as 4 rows. So we have 4, and now we're timesing it by x. So we could say 4 times x, or altogether we could say 4x. So we don't even know, again, why we're talking about these specific numbers and variables, but I will tell you that it is going to relate to that unknown word of polynomial. So let's keep going. Let's keep discovering what we're looking at in number 3. So number 3 says now that we should write an expression that would give the total number of cells in the panel for a solar paneling with x rows and x columns. So it's a little different. Now we have x rows and x columns. So think about what would you do to write down how we could figure out the total number of cells. So instead of 4, like in, number 2, what we could write down is x times x. So when we do that, knowing our exponent rules, right, when we multiply like bases, we can add the exponents, right, because those essentially are an exponent of 1, so that way we will have x squared. All right, let's keep going on to number 4 and see what else we're going to be given that maybe we have to write an expression with, and see what else we're going to change. So number 4, it says if there were 5 panels like those found in item number 3. Oh, so we're saying we have x rows and x columns, but let's say, we had 5 different solar panels, 5 different sets of these x squared number of solar cells. It wants us to write an expression to represent the total number of solar cells. So what we are doing is essentially we have one panel, which is x squared. We have another panel, x squared. We write this out 5 times. So we're thinking of pictures that are represented for each of these. Now to count how many I have all together, right? We don't multiply them together. We actually add them together. So looking at this, right, we can kind of go back to that idea of combining like terms, right? every single one of these is an x squared. And we can think of the number 1 in front of all of them, right? So that way we're adding them all together. And that way we will get an answer of 5x squared. So it's really taking our idea above and saying, hey, we have 5 of these. We're doing 5 times x squared. So what's the purpose of looking at, solar panels and the solar cells within them? Well, all the answers to what we just looked at, they are called terms. So let's go back up to number 1 through 4 and let's write down, or actually let's highlight. Let's highlight what we got for all the answers. So for number 1, we got an answer of 16. For number 2, we got an answer of 4x. For number 3, we got an answer of x squared. And number 4, we got an answer of 5x squared. So you can see in these answers, maybe we had just a number by itself, a constant. Maybe we had a number and a variable. Maybe we had a variable with an exponent, or maybe we had a number, a variable, and an exponent. So all of those, we're going to see, those are all called terms. So now we're going to see what an actual term is. So a term is a number, variable, or the product of a number and or variable. Well, we also have the letter S on the end there, so maybe we're going to see in the future that we can multiply different variables in there, not just, x, but maybe we could have x and y, or we could have, a multitude of different variables together. So looking at this, okay, so referring back to kind of what we did before, number 5 says write an expression to represent the sum of all your answers from 1, 2, and 4. So I'm going to put a star by those numbers. So number 1, 2, and 4. So it wants us to write an expression where we have the sum of all of those. So as a clue, remember, sum means we're adding them all together. So I want you to go ahead, go down below, and write what you think that would be. All right, so for item number 1, we had 16. We add it to number 2, which was 4x. And we add it to number 4, which is 5x squared. Now, if we zoom in to this answer, we can see, even though we're adding them together, we have to leave it just like this because we can't combine unlike terms. This is just a number, this is just an x, this is an x squared. We just write it as the sum of those answers. And in the future, we're going to learn about, okay, if there's a specific order in which we have to put these. So now that we experiment and explored this, let's go ahead and we're going to go on to the next page and start looking at some of the vocabulary that goes along with this. So we're on page 356 and we are going to go ahead and zoom in to the top part up here where we start looking at some vocabulary. We are definitely going to be looking in the margin as well, so keep that in mind. So let's start looking up at the top where it says expressions, like the answer in number 5, they are called polynomials. Polynomials can be a single term or the sum of 2 or more terms. Now, an important part here is that they have to have whole number powers. So what we learned about a little while ago when we had fractional exponents or fractional powers is that's not what a polynomial is. So we're going to stick with whole numbers. So maybe we have 1, 2, 3, 4, 5, 6, and so on. We're also going to learn about maybe 0 being a possibility, but we're not going to have like a half or 3 halves or, 4/5, anything like that. So we have this new vocab word of terms. And we just learned that a polynomial is, looking at just maybe 1 term, 2 terms, 3 terms, but we are adding different terms together. So it says, list the terms of the polynomial that we wrote in item number 5. So let's write them down separately, okay? So we had 16, we had 4x, and we had 5x squared. So now, looking in the margin, we're going to learn another vocab word. I know, this section is really heavy on vocab. So for those of you who really like to refer back to different vocabulary words, this is the section you want to look at. If some of you like to use Quizlet to quiz yourself on knowing different vocab words, you definitely want to pull from this section. So looking in the margin, we have another word. It says coefficient. So a coefficient is the numeric factor of a term. So they're asking us, okay, what are the coefficients of this polynomial? Now, it does give you that definition right there, the numeric factor of a term. What I like to say kind of in like AKA Miss Graham's language, you know, since I'm not always that hyped up on having everything so fancily explained. So what I'm saying a coefficient is it's the number in front of your variable. So it's asking us for what the coefficients are in the polynomial in number 5. So the coefficients are the numbers in front of our variables. So if we wrote down, you know, for x, we know the coefficient is going to be the number 4. If we wrote down 5x squared, the coefficient will be 5. So we know our coefficients, they are going to be 4 and 5. Now, going back to what we had in the margin, okay, it's now asking us for a constant term. Now, we know what a term is already, but constant is a specific one. It's the term that contains only a number, such as our answer to number 1, 16. So the constant term of a polynomial is a term of degree 0. We're going to come back and talk about that, but let's look up above what we talked about. We can see 16 is the number that's by itself. So that's going to be our constant term. So constant term. Now, a lot of the times you'll hear a teacher say constant most of the time. We do like to say constant term whenever we can, but constant is the same thing. We know that's going to be 16. Now, I'm going to kind of go off to the side and explain what it really means for the constant term of a polynomial as a term of degree 0. We're going to go off to the side and explain that. So let's think off to the side. So think back to our exponent rules. Think back to what it means if we had a 0 exponent. So we know if we had 0 as our exponent, that this whole term changes to 1. So think about what if I wrote down 16x to the 0. What would that be? Well, that would be 16 times 1, right? Or it would be 16, right? So this idea is what we refer to back with our constant term. If the number is by itself, we could write it as 16x to the 0, or we could just write it as 16. So it's kind of fun how math comes back into play from what you learned earlier on in the year. All right, so we're going to do a quick check-in right now, all right? So we're going to go ahead and look at numbers 8 and 9 for this check your understanding piece right here, what we just learned about. So I'm going to scoot over into the margin. I have room on my right side. You might have room on your left side, but we're going to go ahead and look at problems number 8 and 9 to kind of test out what we know. Let's first start off looking at number 8. So think back to what we learned with what a polynomial is. Think back to that definition. And what it wants us to do is tell whether each expression is a polynomial. Now for the explain your reasoning part, what I'm going to do is I'm just going to highlight, okay, which part makes it not a polynomial. So that's what I'm going to kind of refer back to if it's not a polynomial. I'll highlight that, but I want you to go ahead and pause the video right here, answer each of these questions in the margin, and then we're going to go ahead and go over them. Alrighty, let's go ahead and take a look at our answers. So just as a reminder, when we're looking at whole number powers, remember that means all of the exponents have to be positive. So not just a whole number, but whole number refers to being positive, not just fractional pieces. So looking at all of our answers and all our results, we can see option A and D, they are not going to be polynomials because for part A, we have a negative exponent. For part D, we have a fractional exponent. But we can see for parts B and C, yes, we are going to have polynomials because looking back at our definition, it can be a single term or it can be a sum of two or more terms as long as they are whole number powers. So that's exactly what we have. We have a single term and we have multiple terms here. So now that we practice number 8, we're going to go ahead and look at number 9, where it says for the expressions that we just wrote in number 8 that are polynomials. So hey, for part B and C, it wants us to identify the terms, coefficients, and constant terms. So again, over in the margin, right, for number 9, we're going to be looking at 6x plus 4x squared. And we're also going to be looking at 15, and we're going to have to identify if there is, what terms, coefficients, and constant terms there are. So I want you to go ahead and pause the video right now and try that on your own. All right, let's go ahead, look at number 9. All right, so for our first polynomial, our terms are 6x and 4x squared. Our coefficients are 6 and 4. And there's no constant, there's no number that's by itself. So we realize that sometimes there won't be a constant within our polynomial. Looking at 15, we know the terms, there's only one term, it's 15. There's no coefficients because it has to be a number in front of a variable, but our constant, the number by itself, is 15 itself. So we have learned a lot of vocabulary here, and we're going to continue to learn some more vocabulary words in the next section below. So let's go ahead and start looking at right above where we have number 10. So I'm going to scoot this up a little bit. We're going to definitely build off of what we already know, those vocab words, but we're going to add another one, all right? We're going to learn what a degree of a term is. Now, it's not the deodorant, and it's not something you get when you graduate, okay? So the degree of a term is the sum of the exponents of the variables contained in the term. So we're going to practice identifying what this degree is, along with practicing, the coefficient of each term in our polynomial. So this is our whole entire polynomial, right? There are 1, 2, 3, 4, 5 terms. So we can see this first term is 4x to the 5th. We're going to focus on that. Then we're going to do 12x to the 3rd next, then x squared, then a negative x. We're not going to look at that last constant number because we really want to focus on the first 4 and understanding what is the degree and what's our coefficient. We'll come back and look at that then. So they did the first one for us. So the degree is really the sum of the exponents in the variable. Now each of these terms only has one variable. So it's actually kind of nice to start to look at this because it will always be the exponent. Now, if your exponent isn't there, remember we can always put a 1 there to figure that out. So we know, again, since all of these only have one variable, that we can write down the degree as what that exponent is. So for the first term, it's 5, the second one is 3, the third one is 2, and the last one is 1. Now, I want you to practice writing down what the coefficient is for each of these. So pause the video and then come back and we'll check your answers. All right, let's check. You should have gotten 4. We already have 12. 1 and a negative 1. Don't forget about the negative that's in front, right? Even if the number isn't there, it's not 0. It's going to be 1 in this case. So looking at the degree of a term here was pretty easy when we only have one variable with each term. But now let's step it up. Let's look at number 11. So it says for the polynomial, 2x to the 3rd y minus 6x squared, y squared, plus 9xy minus 13y to the 5th plus 5x plus 15. Oh my goodness. It says list each term and identify its degree and coefficient. Identify the constant term. Holy cow, we have a lot that we have to look at here. And remember, we're looking at the sum of the exponents of the variables within our term. So we have multiple variables within here. So what I'm going to start off doing is I'm going to kind of make a table just like I had before here, filling in all of the terms, except the last one because I know that's our constant. So I'm going to go ahead, I'm going to zoom down a little bit. I'm going to go ahead and make a little bit of a table so that way I know I can fill in my information. Just like I have above, I'm going to divide it into 3 parts. And what I'll do at the top is I'll say this is my term, this is my degree, and this is my coefficient. And like I said before, our constant term is going to be 15. So we can identify that. I'll put that over here, that our constant is 15. So we got that out of the way. Now we have to go ahead and put all the terms in here. So let's start off with our first one, 2x to the third y. Then the next one is a negative 6x squared y squared. Then we have 9xy. Then we have 13y squared. And then last but not least, we then have 5x. So I'm going to go ahead and try to make some sections so that way we can see easily, okay, what we can fill into each spot. Let's go ahead and we're going to start off working at the bottom all our way up because these only have one variable to start off with. So let's start off with kind of the easier ones. So looking at this, right, we only have one variable, so we can easily look at what the exponent is. In this case, if there's not an exponent, we can write the exponent of 1. So we know here our degree is going to be 1. Looking up at the one above, we had 13y squared. We know that there's only one variable, so we're just going to look at the degree. The degree is 2. Now, let's focus in on these last two, looking at what our coefficient is. That's the number in front of the variable. So for the bottom one, it's going to be 5, and then the next one is going to be 13. I'm going to go ahead and try the one in the middle, the 9xy with you. I'm going to go ahead and practice doing the degree and coefficient, and then I want you to test the next two on your own. So looking at this, since we have two variables, we have to look at both of their exponents and look at the sum of them. So remember, if the exponent isn't there, we can always assume it's a 1, and I have to make sure I do that for the y as well. So what we see is we have 1 and 1. We want the sum of them, right? That's what our degree is. It's going to be 1 plus 1, so our degree will be 2. So that's what we're looking at, how we add these two pieces together. And then our coefficient is going to be the number in front of the, the two variables. That's going to be our 9, which we have right there. So I'm going to write 9 as our coefficient. Pause the video right here, and I want you to test out, our first two terms, see if you can figure out the degree and coefficient. All right, let's check to see what we got. All right, so for our first term, we should have got a degree of 4 because 3 plus 1 is 4, and our coefficient is 2. For the second one, we should have gotten 2 plus 2 is 4 as our degree, and our coefficient is a negative 6. Don't forget about that. All right, sweet. We got a little bit of practice looking at the degree of our polynomial. Whoop, whoop. All right, let's go ahead and turn to the next page, 357. So now we're on page 357. We're going to go ahead and go up to the top, and we're going to expand upon, a degree of a term with now looking at a degree of a polynomial. So the degree of a polynomial is the greatest degree of any of the terms within the polynomial. So we're looking for the highest exponent, the largest power. So let's go ahead and look down and says, identify the degree and constant term of each polynomial. Great, so that's what we're going to look at. But then, right, instead of degree of the term, it's the degree of the polynomial. Let's start off with something we know. Let's start off with that constant term. We're so familiar with that, right? That's kind of the number that's by itself. We started off with 36 as our last example right there. And we can see when we have different terms, it doesn't necessarily matter what the order is currently. We're going to learn about that shortly, but we can see in our third example, the constant came first. If we look at our first example, we can see, whoa, our constant actually comes last. So it's going to be 7. For our second example, we can see our constant is right here. Remember, it's not just 3. It's a -3. So we have to make sure we include that sign as well. So now, here's the fun part, right? We're looking at the degree of the polynomial, right? Of the polynomial. That means what's the highest exponent. So we have to look at all the exponents. So I have an exponent of 2. Technically, I have an exponent of 1 I could put there, right? So the highest out of those is going to be 2. So the degree of my polynomial is 2. Looking at our next polynomial, right? So we have 3, 2, and then technically, remember, we have a 1 there. And kind of like what we talked about before, there's a 0 degree right here for the y. But the largest one, right, the largest exponent is going to be 3. So the degree of our polynomial is 3. Now, last but not least, okay, we can see that this has an exponent of 1. I always like to add that in there. And then this is an exponent of 2. So we take the highest one, even though it's our last term. So our degree of our polynomial will be 2. Now, in the future, we're going to learn there's actually specific names for when we have a degree of 2 or degree of 3. We're going to learn what those are, and we're actually going to learn about, okay, depending on how many terms I have, there are specific names for each of the polynomials for that. I know. Get excited about this. Woo woo. So before we encounter all of that, we're going to look at now, okay, the order of each of the terms. Does it matter? Does it not? What's going to help us out? So looking down below, I'm going to zoom out a little bit. Start to look down below at the standard form of a polynomial. So here, what I'm going to see is the standard form of a polynomial is a polynomial whose terms are written in descending order of degree. So over in the margin over here on the right side, it tells us what descending order means. So descending order of degree means that the term has the highest degree written first. Then the term with the next highest degree is written, and so on, all the way down to the smallest or lowest degree. So before we look at this next vocab on here, let's look at this. We know at 7x to the 5th plus 2x squared minus 3, we know each of these are terms. We know -3 is our constant. And the degree of our polynomial, right, is the highest exponent, it's 5. When we're putting it in standard order, that means I put this term first because it has the highest exponent, 7x to the 5th. I then add it to the next highest exponent, which is 2x squared. And then, last but not least, I'm going to put my lowest exponent, or really what my constant is. So if I rewrote this and wrote -3 plus 2x squared plus 7x to the 5th, it would not be in standard form. It would not be in that form. So let's just practice doing an example off to the side. All right, so we're going to do an example off to the side, practicing putting all of these terms in standard form. All right, so I'm going to go ahead. I'm going to write down an example. Perfect. So 2x minus 4 minus 15x cubed plus 4x squared. I want you to put that in standard order. So go ahead, pause the video, try putting that in standard order. All right, so the standard form, right? We want to put this in standard form. We have to pick the term with the highest exponent. That's -15x cubed. The next is adding 4x squared, then adding 2x, and subtracting 4. So this is going to be our standard form. So now that we got to practice that, let's go ahead and look at our next vocab word. So going back up to here where we last left off, it says the leading coefficient. So let's highlight that. So The leading coefficient is the coefficient of the polynomial's leading term when a polynomial is written in standard form. Oh, so that's why we're talking about standard form. So we have this polynomial in this order, and we're looking at the coefficient, remember the number in front of our variable, of our leading term. So let's talk about leading term, all right? This first term, that's what the leading term is. So leading term, we want the number that's in front of its variable. So that's 7. So our leading coefficient here is 7, as we can see pointed by the arrow. So on the example we did off to the side, I want you to see if you can find the leading term and the leading coefficient. All right, so our leading term is negative 15x to the third. So that would make our leading coefficient negative 15. So I'm going to write that down. So that is our leading coefficient. So it's good to practice this on different examples because we're going to see them in the future. So let's keep going with all this new vocabulary. I think you're at a point where you're like, ooh, yeah, we learn a lot of vocabulary. I'm definitely going to use Quizlet or maybe make some flashcards to practice knowing these. Hey, guess what? We're going to learn some more vocabulary. Woo woo! All right. A polynomial can be classified by the number of terms. Remember when I said we were going to look at that? Yeah, that time is now. So we're looking at classified by the number of terms it has when it is in simplest form. So that's the forms that we've been looking at now. That just means, we are able to combine any like terms and there's nothing else that we can add or subtract together. So looking at this table, we have some other vocab words that we are going to start looking at and distinguishing. So we have this word called monomial. We have another word called binomial, another word trinomial, and then all together we're going to look back at polynomial and what that means in relation to these three new vocab words. So monomial. Now we're going to go back to kind of the roots of words. That's what we're going to look at. I know, quite an English class. The word mono actually means one. So what we're going to realize is when we just have one term, that's called a monomial. So earlier in the lesson, right, when we were looking at the solar panels, right, we had 16 as a term. That's called a monomial because it has a number of terms, n, which is 1. So we could have 8. We could have negative 2x. We could have 3x squared. Those individually are all monomials. So again, going back to the roots of the words, if we look at binomial, the first part, bi, actually means 2. So mono means 1, bi means 2. So that's how many terms there will be together, added or subtracted. So an example could be 3x plus 2. That's one binomial. Or we could even say 4x squared minus 7x. That's another binomial. Now, if you're catching on, you're probably thinking, ooh, all right, we did one term, two terms, probably 3 terms is next. And you're right. Tri, just like, a tricycle, right? It has 3 terms, just like a tricycle has 3 wheels. Just like, a bicycle has 2 wheels, right? Unicycle only has 1 wheel. It's not called a monocycle. That'd be interesting. But anyways, let's go back. Let's not get Ms. Graham off topic too much. But trinomial means there's 3 terms altogether. So the example that we have is negative x squared minus 3x plus 9. And then polynomial means if we have 4 or more terms. That's what this expression means. N is greater than 3. So I'm going to write that out in words just in case. So 4 or more terms. So here we have 4 or more terms. We actually have 5 terms for that example right there. So again, off into the margin, the reading, right? Just kind of telling us about these prefixes, right? Mono means 1, bi means 2, tri means 3, and the word poly actually means many. So that's why we reference it back to 4 or more, right? These appear in many different math terms. Now, next year in geometry, you're going to see something like bisect cut in half. we're going to focus on triangle, 3-sided figures, and polygons, many-sided figures. So that's a preview of what you'll see when you reach geometry. Let's go ahead and head to the next page. Now, at this point in time, your teacher is going to be assigning you what your homework is for tonight, all right? Because I know this was a little bit of a bigger lesson, looking at our vocab. For Miss Graham's class, we are going to be looking at page 358. So we're on page 358. And I want you to do number 13 for homework. That means you are completing this table. You have all these different examples of polynomials, right? A binomial, a trinomial, monomial. We go through. I want you to tell me the number of terms, what that name is, what we just learned, like monomial, binomial, trinomial, polynomial. I want you to tell me the leading coefficient. I want you to tell me what the constant term is, and I want you to tell me the overall degree. What's the degree of the polynomial? All right, so that's what our homework is for tonight. We're going to come back tomorrow and talk about that. So again, if you don't have Miss Graham as a teacher, check in with your teacher on what your homework is tonight. Have a great day and happy mathing.